Okay everyone, welcome back to the Population Ecology lecture series. Now what we're going to do is go over the math behind these models now that we've looked at it graphically. And I'm going to go over the rates that we had in that last lecture and make one correction. So we have little b, which is the per capita birth rate, and beta, which is the infection rate. So this is a rate of babies coming into the susceptible population, and this is the rate of susceptibles moving into the infected bin from the susceptible bin. Next we have the gamma, the rate at which immunity is lost in recovered individuals, so they're moving back into the susceptible population. And then this V, which is the recovery from infection or a parasite attack, the rate at which they move from the infected into the recovered bin. We have little d, which is non-parasite death rates, and alpha, which is parasite death rates. And that's a little correction I wanted to make. The reason that people use alpha for that one from infected to death and d for everything else is that that's assumed to be the parasite related death rate. And these little d's are non-parasite related death rates. Okay, so with all that being said, we can go into each of our groups and just plug in these values into the model. And let's start with our susceptible bin. D of S over D of T is going to equal our birth rate times the number of individuals in susceptible plus individuals in infected plus individuals in recovered minus that non-infection related death rate times the population size of the the susceptibles, minus the rate at which they're going into the infected bin, which is beta times S times I, plus the rate at which recovered individuals become susceptible individuals, which is going to be this gamma times R. Okay, so now we can move into the infected bin. I'm going to sit down for this one. So the rate at which we get individuals into the infected bin is beta times S times I. Now we want to look at the rate at which we lose individuals, so that's going to be this plus D plus V times the population size of that infected population. Okay, so the last one is going to be our recovered population. That is D of R over D of T is equal to, we're looking at the rate at which infected individuals become recovered individuals so that's V times I, minus the non-infection related death plus the rate at which individuals move from recovered back into susceptible populations, so that loss of immunity, times the number of individuals in that recovered bin. Okay, so it's pretty simple math. All this is mathematically expressing what I showed you using those bins in the last lecture. So that's it for this lecture. What we're going to do next is just briefly talk about the host-parasite dynamics from the perspective of the parasite, And then we can move into Populus and start playing around with those models.